Hi there. Let me walk you through CuttingEdge, which is an extension to ENCY. Using the CAM API, I've extended ENCY to support a cloud-based feeds and speeds library. And feeds and speeds are applied a bit differently than what you're used to. They're not just stored on the tool anymore, but feeds and speeds are actually determined by several factors that combined together will give you a set of feeds and speeds. We will look at the part material, the tool diameter, and lastly, a machining method, and that's what we apply our feeds and speeds to. This allows the CAM programmers in a company to collaborate and build out the company's cutting data over time. Let me quickly explain what I mean by a machining method. It is not a one-to-one with the CAM operation type, because if you think about it, let's take 2D contouring as an example. That can be used for a wide range of different operations, and you wouldn't want to use the same feeds and speeds for any 2D contouring operation, even though you're using the same tool material, part material, and tool diameter, for example. That's not good. So instead, you will apply a machining method on top of these factors. And CuttingEdge will actually suggest a method based on the operation and the parameters that it can see. In addition to feeds and speeds, a company will build up a database, if you will, of machining knowledge that spans more than just feeds and speeds, but also operation parameters like tolerances, ramp angles, width of cut, depth of cut, etc. And CuttingEdge can optionally also apply these when you choose a cut method. And that's enough theory. Let's have a look at what it actually is. And we'll start by looking at the Cloud UI, which is a web-based application. Now we're logged into CuttingEdge, and let's have a look at the configuration first. So we'll start with the workpiece materials. That's just a list of the materials that you're machining in. Next up is the tool materials, which is the material of the tools, but with a little bit of a twist. And notice this slug over here. We'll talk more about that in a second. Lastly, we have the machining methods themselves. And those are also just a list with a name and a mode, which can help us filter out some of them when we can't really use them, and the ability to add more and delete. And this is when the fun starts, so let's hop over to cutting parameters. At the top of the cutting parameters, we have some filters. And again, you can see here the workpiece material, the tool material, and the machining method. So let's look at roughing strategies, for example. So we're now looking at roughing with the carbide tool in aluminium. And we'll go into this 10mm tool. The top section here is just about feeds and speeds. So for a 10mm tool in aluminium, roughing with the carbide tool, we have a surface speed of 400, an RPM of 12,000, chip load of 0.1, and that gives us a feed rate of 3,820. So if we were to change the surface speed, of course that will affect the RPM and the feed rate. And if we change the chip load, that's only going to affect the feed rate. And if we manually change the feed rate, that will then update the chip load back. If you want to check this speed, what would that do if we had 4 flutes, for example, or 5 flutes? You can do that. But it's important to note that we're not actually storing any information about flutes, and we're not tying this information to any specific tool. We're just tying it to roughing with the carbide tool in aluminium. The next section here is completely optional. You don't have to use operation parameters at all, but if you apply this method inside of ENCY to an operation, and these can be matched to an operation parameter, then they will be applied. And a nice thing in there is, for example, coolant. So if you were to go to cutting parameters and you're using a carbide tool with coolant holes and you want to do some drilling, for example, let's pick one here. Then maybe you want to do internal coolant because that's supported by your tool. That's one way of using that. So now let's hop into ENCY and have a look at how this is integrated. But before we do that, we have to create a token for ENCY so that it can talk to CuttingEdge. So we'll go up here to API tokens, and we'll create one for ENCY. And ENCY as of now only needs read permissions, but later if we want to be able to update tools from inside of ENCY, then we would need those additional permissions. So let's create our token, and I will delete this after the screencast, so it's okay that you see it. Now let's go to ENCY. All right, so we're finally in ENCY. Let's have a look at the setup of CuttingEdge first. So we'll go into the configuration, and here you can see I've entered the token that we just created, and I've set some defaults. So my default workpiece material is aluminium, and my default tool material is carbide. And this one is a bit interesting because there really isn't a tool material selection inside of ENCY currently. So what we do is we set a default, and if you remember from the web UI, we have these slugs. So if the description of a tool contains a slug, then it's automatically going to say that, okay, we saw HSS in there, so this is going to be an HSS tool. And this is then going to change the feeds and speeds completely, of course. Some operation types are easy to recognize in ENCY. For example, we have roughing waterline, so you can set a default. So when you create such an operation, it's going to suggest that you use the roughing cut method. Same for face milling, same for drilling, helical interpolation, and tapping, ball finishing, etc. What's interesting here is, of course, that the drilling, helical, and tapping, they're all hole operations. But we look slightly deeper into these to figure out what kind of operation it is and suggest a better default. Okay, so that's the setup done. Now let's look at the part setup. So let's go over to our part and select part setup. And you can see our default is already set. It's aluminium. But here you would choose what kind of material this part is. Let's hit OK and move over to our first operation, which is this roughing waterline operation. So let's right click and choose set cutting parameters. Notice that it's defaulting to roughing, and we have this checkbox for apply operation parameters. And this is on by default, and it will also then apply the operation parameters if you set some in CuttingEdge in the web UI. But if you don't want to apply those and you just want to apply feeds and speeds, then you can uncheck that one. And there are some cases where you want to do that. Also, before we hit OK here, have a look over at the current feeds and speeds. And they're just set to the defaults because there are no feeds and speeds information in my tools. So let me hit OK. And you can see that I got the spindle speed and I got the work feed, and also the rapid feed was updated actually. Let me change the coolant here and do set again. Hit OK. And you can see that the coolant is then updated because that was part of the operation parameters that was set on this specific configuration. And now, if you look at the tool name, you will see that it says chip breaker. So it matches the slug for this tool. Let me show you. If we go to our tool materials, we have carbide with chip breakers, which will then match the chip breaker slug. So in our tool, since it says chip breaker there, that's the tool feeds and speeds we get. So that would be the combination of aluminium, carbide with chip breakers, roughing, and our 10mm tool. And 7219 seems to match quite nicely. But we also have, let's say, aluminium, carbide, and roughing. So the normal strategy for tools that doesn't have serrated cutting edges. And here we have a more reasonable feeds and speeds for such a tool. So if we were to change the tool for this operation, let me choose, for example, this tool, which doesn't have serrations and it doesn't have that chip breaker in the slug or in the description of the tool. Now let's now reapply. And you can see we then get the correct feeds and speeds for that combination of material, tools, and operations. Pretty neat. Let's move on to flatland, which is a finishing operation with an 8mm end mill. So finishing is selected, and that's going to update our feeds and speeds as well. Interestingly, let's try to change. Let's say this one was set to mist. And yeah, I'm just gonna apply to the tool feeds and speeds for now. And reapply. You'll see that it updates the flood coolant as well. Now let's try some of the others as well. So if we go to this drilling operation, we will get our feeds and speeds. And spot drilling, for example, let's try that one as well. That would then be, and here, you know, it can't help us the first time. We have to select one, but then it will remember it, of course. We might even want to build this out with the detection of tool type so that we can combine those to find an even more suitable cut method by default. But let's use this one and get our feeds and speeds. And you get the point. It goes on like this. And that's really all there is to it. And I'm going to build it out with more options, like, for example, going from here and updating the cloud library. And I have some other ideas as well. But already it's really helping me out in the day-to-day, and it has made ENCY so much more powerful for me. All right, so I hope you like this short introduction to Cutting Edge.